So now that we have our rock types done, we can move on to the principles of relative dating. You can see here there are 5. Well, there are actually more than 5 principles of relative dating, but that will be good enough for what we need to do in this class. The first principle of relative dating has the longest name ever. It is called the principle of uniformitarianism. So uniform, Arianism. Uniformitarianism. The base here is uniform. Uniform means the same. Like if people wear a uniform, they're all wearing the same clothes. Uniformitarianism is a philosophy. This is kind of a key thing. This is not a definition. This is a way of thinking. Prior to uniformitarianism, there was a philosophy called catastrophism. And the idea was that if you saw something really cool in nature, it probably happened from a huge disaster, like a flood, a mega eruption, some kind of huge earthquake. And there was this guy named James Hutton who said, no, that's crazy. Why couldn't the stuff that happens today happen in the past? So James Hutton came up with this idea that the present is the key to the past. That's kind of his slogan for uniformitarianism. And what it means is that the processes working today can be used to explain the past. By processes, I mean things like weathering, erosion, deposition out in the water, like rock settling out of the water. So weathering, erosion, deposition, yeah, volcanoes, yeah, earthquakes, maybe. Now we would add plate tectonics too, but James Hutton didn't know about that. He was a farmer in Scotland quite a bit before plate tectonics was developed. But because of his ideas here and how they helped form modern geology and kind of keep us all saying, let's go with the simplest option. If we find a canyon like the Grand Canyon, probably happened slowly through erosion, not through a huge flood. James Hutton is known as the father of geology. He's the father of geology, or the father of modern geology. Both work because he's telling us to keep it real. We don't need to use magic, fantasy, huge disasters to explain what we see. The processes working today are probably the same processes that were happening in the past. And the next principle, starting now, these are not philosophies. The first is the principle of superposition. The idea with superposition is that if you have layers of rock, each bed of rock is going to be older than the one above it, younger than the one below. So if you went out and you found layers of rock when you were on a hike, you would know the oldest is at the bottom and the youngest is at the top. A guy named Nicholas Steno came up with this back in 1669 when he was hiking through the Alps in Europe. I don't usually tell you the age of everything and when it came up with, but I think it's pretty cool that this one is from 1669. That's very old. And it's very simple. He's really just saying, okay, it makes sense. If you find sandstone underneath shale, underneath limestone, well, the sandstone's probably the oldest. Because sediments don't get tucked underneath. The new ones always get put on top. The next one is the principle of original horizontality. 2 words. Original, horizontality is like horizontal. Like horizontal, but then you add 80 at the end. Horizontality. Layers of sediment are deposited in a horizontal position. Like I just showed here, these layers, they're all flat. Horizontal. matching up with the horizon. But if you find them later on, and they're not horizontal, then you know something happened later to cause them to be tilted. So it's the same sequence, sandstone on the bottom, then shale, then limestone, but in this case, they're no longer flat. So they got tilted later on. So they were tilted after deposition. So if you saw this, you'd be like, nope, it didn't start that way, because mud would not stack up like this. Sand would not stack up like this. They would always, gravity would always pull them flat. And if they're like this, they got tilted later. Now you may be asking yourself, like, what would tilt them? Well, maybe they got tilted from plate tectonics. Maybe from an earthquake. Those are kind of the two big ones. Maybe a landslide, but that's not as likely. The next is the principle of cross-cutting relationships. Cross-cutting means it cuts across. The relationships just shows two things are involved here. So relationships. Cross-cutting relationships. A fault or intrusion is younger than the rock layers it cuts through. So remember, a fault would be like an earthquake fault. Two sides moving in opposite directions. An intrusion would be magma that had burned its way through the layers. If you see earthquake movement, you know rocks had to be there before the earthquake could happen. It happens because of tension in the rock. If you see magma burning through layers, well, you know that the layers were there first, because otherwise the magma would just puddle out as lava on the surface. So if you see it kind of cutting its way up through the layers, then you know that the layers were there first. And the last is the principle of inclusions. Principle of inclusions. Pieces of one rock type that are contained within another rock type are older than the surrounding rock. A really good example for this one is going to be our conglomerate. Conglomerate is a mini version of this. But up here, maybe we would have some pieces of igneous rock trapped in our sandstone. That igneous rock had to have existed in order to get into the sandstone. So with conglomerate, remember, you have pebbles that have eroded out of pre-existing rock, and they're just hanging out on the surface until maybe some mud or some other kind of fine-grained rock fills in the gaps between them, and the whole thing lithifies. And now you have a conglomerate. This also looks like a chocolate chip cookie, and that works pretty well too. If these were chocolate chips, well, think about it. With the chocolate chip cookie, you don't start with dough, put it in the oven, and hope chocolate chips appear. You start with chocolate chips, you add the dough around it, put it in the oven locks them all together into one cookie. That's how conglomerate works. The earlier pebbles get included to form a new rock. Same thing with rock layers that have pieces of one rock type contained within another. The old rocks are included in the new layer. So I'm going to draw one picture over on the right here. And basically it's going to be an end story. So we'll have a few different layers. So I'm going to have some sandstone, I'm going to have some shale, and I'll have some limestone. That's kind of my favorite pattern to do. So we have 3 different layers here. Sandstone first, then the shale, then the limestone. That's superposition. Oldest is always on the bottom. But what if we had some magma come up from below and burn its way through? Now this magma has melted away the sandstone and the shale that it's come through. This right here. This is our intrusion. It is younger than the layers that surround it. Sorry about those bubbles. The intrusion is younger than the layers that it's intruded through. And maybe, just maybe, in our, let's say in our limestone, we have some pieces of shale. Oof, I shouldn't have made those green. I should have made them purple, just like the shale. So if we have some pieces of shale, you know that mud's not going to form in the middle of a limestone. You would assume that they came from below. So those are inclusions. And they're probably the age of the rock below. So the age of this whole story would be sandstone, shale, inclusions, limestone, and finally that intrusion would be the most recent event.